7 years after full-scale development began, a Peacekeeper missile, the 9th in the test series, sits in its launch facility at Vandenberg Air Force Base, California, awaiting the first silo launch. Peacekeeper, the United States' most advanced and technically sophisticated ICBM, is a 4-stage system that will deliver up to 10 Mark 21 independently targeted reentry vehicles over 5,000 miles to their targets and deliver them more accurately than any previous missile. Peacekeeper is nearly 3 times the weight of the Minuteman III at approximately 195,000 pounds and is 71 feet long and 92 inches in diameter. It is designed to be ejected by a gas generator from a canister placed in a modified Minuteman silo. The missile ignites after ejection rather than in the silo like previous ICBMs. The Air Force Systems Command's Ballistic Missile Office, BMO, headquartered at Norton Air Force Base, California, directs the design, development, construction, testing, and operations of the Peacekeeper program by integrating the efforts of highly skilled teams of associate contractors located across the United States. The Air Force Western Space and Missile Center at Vandenberg Air Force Base, California, is the nerve center for all Peacekeeper flight test launch operations. Here, the design, fabrication, and pre-launch testing come together in the ultimate realization of the years of planning and efforts on the part of thousands of people who have contributed to the program. Since June 1983, Peacekeeper's flight test program has reached new technological heights. The first 8 test missile launches were from above ground. Here, potential problems were evaluated, irregularities identified, and corrective actions implemented. The remaining 12 test missile launches will be from canisters located in modified Minuteman test silos. This first silo launch will use the new Peacekeeper operational and flight support equipment and procedures. An additional objective of this first silo launch is to evaluate the performance of the 6 Mark 21 reentry vehicles. These flight test efforts are essential milestones in the development program that leads to Peacekeeper's deployment. 3 of Vandenberg's Minuteman launch facilities have undergone major modifications both in preparation for this flight and future silo launches. These major modifications were started in early 1984. The Minuteman silos were completely stripped of equipment and have been reconfigured to support the Peacekeeper missile system. Launch Facility Number 5 will initially be used for ground testing, while Launch Facility Number 8 is to be used for the current flight test series. An additional launch facility, Number 2, is being modified to support test launches beginning in 1986. The silo equipment installed includes both the missile shock isolation system and the electronics to operate it. In a fully operational mode, the shock isolation system, with its cables and foam-like pads, will support the canister and protect it from a nuclear blast, and thus help maintain Peacekeeper on alert. A series of shock isolation system development tests were conducted prior to their installation in the test silo at Vandenberg. Foam drop block tests simulated silo wall motion during induced ground shock. During the vertical shock development tests, a simulated missile and canister were dropped from heights up to 35 inches to simulate vertical ground shock. 2 other major launch support facilities were constructed near the Vandenberg silos. One, the modified underground launch support building located near the launcher, provides standby power generators and air conditioning environmental control equipment. The other, a newly constructed underground launcher auxiliary support building, is located at the edge of the launch facility. This building, used only at Vandenberg, provides launch protection of critical test instrumentation equipment and communications hardware. After construction was completed on the launch facilities, the missile assembly and other launch preparations were started. For flights 1 through 8, all missile subsystems came together at the Missile Assembly Building. The missile was assembled vertically, with each major component, the motor stages and re-entry system, being mated together inside the canister. The canisterized missile was then transported to the test launch stand. For this first silo launch, the empty canister is installed in the silo, and the stage is mated and checked out there. To start the assembly sequence, the canister is placed on the rotation fixture in the high bay area of the mechanical maintenance facility. The shock isolation system, air elevator reel, and support equipment are installed. After the canister is instrumented and system checkout is concluded, the completed unit is driven to the launch facility. There, the canister is lowered into the modified Minuteman silo and readied for buildup of the missile itself, which is comprised of 3 solid propellant motor stages, 1 liquid propellant engine stage, and the guidance and re-entry systems. Peacekeeper's 3 solid propellant booster motors are checked out at one of the 2 identical stage processing facilities. The stages are received in containers, unpacked, inspected, and instrumentation and flight safety system components installed and verified. Missile assembly and checkout at Vandenberg is monitored and directed by the 6595th Missile Test Group. Pads are installed on stages 1 and 2 to support the missile inside the canister and control its exit. All 3 solid motor stages are then placed in containers and transported to the missile assembly building. There, they are installed in the transportation and handling equipment, which is used to transport the stages to the launch facility. The equipment consists of 2 major components. The Type 2 transporter carries the motors to the launch facility for assembly, 1 at a time. Here, each of the missile subsystems is transferred from the transporter to the emplacer, the other component of the transportation and handling equipment. The emplacer is pre-positioned at the silo. Each stage, in its turn, is rolled into the emplacer, which is then erected to a vertical position. Stage 1 is lowered into the canister and mated to the support assembly. The air elevator then lowers the assembly to the mating level in preparation for receiving the next stage. Stage 2 is then mated to Stage 1. Finally, Stage 3 is mated to Stage 2. The liquid propellant Stage 4 is received and inspected at the installation and checkout facility. Its instrumentation and flight safety components are installed. At the payload assembly building, the re-entry system, consisting of the Mark 21 re-entry vehicles, the antenna, and protective shroud, is processed, assembled, and tested. The completed re-entry system is transported to the installation and checkout facility. Here, the re-entry system is mated to Stage 4. This now completed post-boost vehicle is then checked out and transported to the launch facility, where it is mated to the completed booster. After exhaustive checks of the entire system, control of the missile is transferred to the Peacekeeper Launch Control Facility. The instrumentation and flight safety telemetry will be monitored at the Western Space and Missile Center's Test Operations Control Center. Pre-launch preparation and final countdown checks are performed. Within the last few minutes of the count, a number of commands are entered into the system by the launch team, which brings the Peacekeeper to the final countdown. This first silo launch has demonstrated the ability to successfully launch a Peacekeeper missile from a modified Minuteman silo. Also proven were the modified Minuteman electronics, as well as the all-new electronics, silo support, and launch systems specifically developed for Peacekeeper. In addition, This successful flight once again demonstrated the missile's performance by flawlessly delivering its payload to the targeted terminal area. The test program is designed to support the initial operational capability scheduled for late 1986. Subsequent testing will complete the system demonstration and provide reliability data. Through this successful first silo launch, the Air Force Ballistic Missile Office has continued its series of achievements in the Peacekeeper program. BMO will continue to strive for excellence in the development of our nation's most effective deterrent, the Peacekeeper ICBM.